Hi everyone, super happy to be here. I'm Adam, and I'm here to ask what's going on with bots on the web. So we're going to talk about a couple of things. This works? Wonderful. This one back? Okay. So we're going to talk about simple detections, which means like simple methods to detect bots. We'll get to how the bots got better. So we'll talk about everything containing to how the bots improved over time. Then we'll get to the King bot. This is an open source beast of a bot, one of the best, cheating out most detection solutions. I'll tell you a lot about that, and then we'll get to my favorite part, being how you can still detect that King bot. But first, like one reason I really care about this is going to be because I always liked hacking stuff. I had the chance to speak with some of you. Seems like the mentality at OpenJS is very like breaking things. So me too, I really like it. And currently, I work in DoubleVerify. They do a lot of measuring for ads, and that means part of my job is telling advertisers how many real people see their ads. So that means part of my job is playing tech hide and seek with these bots. I need to find them, I need to detect them, and advertisers are like one aspect of this. We'll dive into why people bot in just a second, but there's actually a lot of people in the game. So there's going to be social media services, there's going to be different kind of concert ticket sellers, there's going to be sneakers inventory, and the reason is that the internet was not designed with bot detection in mind. Seriously, the only real standard out there is going to be robots.txt. So this is going to be the honor system. This is going to be asking the good people to play nice. This is telling bots, hey, can you please go there, not go there? But when you do that, obviously, you're going to run into the bad people doing bad things. But I said bad people. It's a little bit misleading when I say bad people, because real story, when I was 15, high school crawler projects may or may have not dropped service to some site. And this is not because I was entirely unaware of that bots.txt things. It's just 16-year-olds with something to do are not necessarily the most ethically driven creatures on the planet. But just to clarify, this can be done by, if this works, I'll get up there. This can be done by bad people at scale. So this is something like, for example, in advertising, bots, every time you can navigate to a site, every time you can convince an advertiser, they have JavaScript tags that get loaded. If you can convince an advertiser that somebody navigated there without actually getting the user, you essentially have a money printer on your hands. So there's people doing this at scale with a lot of different things. Just one more example to connect everybody up to what the bots are doing. This little article here being how, I don't know if you've ever seen this, but when you go to buy sneakers, for example, there's all these sales and they have the page open. And the page is open for just like a couple seconds. And if you're a real user, you're refreshing the page all the time, you're going to see the inventory run out real fast. Another thing, you see, for example, concert tickets, these are running out super fast too. Meantime, some secondhand resellers are having huge success with those. Turns out there's bots behind that. This is what I like to call the scraping Olympics. So there's a couple bots. They complete to shred off a couple of particles of a second just to buy out the inventory before anybody else. They resell this inventory with a premium, and they're very happy about that. So yeah, there's very nice tech behind that. Some projects open source, some projects I can talk about more or less if you've been in before. But I want to get to the tech part of this presentation, so we're going to start with simple detections. This is not because bot operators are not aware of these, but typically what I'm going to talk about here will be the basis for anything more complex you do. I'm going to talk about first some simple detections, just straightforward things that really let you know that the thing in front of you is concretely a bot. I'm going to tell you how the bots patch these, how they improve, and then we're going to talk about how this cat and mouse game led to the state-of-the-art bots and detections that are out there. So first, very simple stuff. User agent, you people know this, but I'm going to say it anyway. This is the request header that identifies your browser to whatever it is that you're going. So let's say a site. I have a website, I have a service, and I see many users coming to me. I'm looking at the user agent. Could be the actual network property, could be the navigator property. This actually saved in JavaScript. I see this thing is Python, probably not a real user behind that. And the detection folk, this is like 20 years ago. This is all tech. The detection folk, they did this. So if they see certain user agents, obviously they block them. And the bots haven't been sleeping on their guard. So they patch it. And then the detector folk have to come up with something new. Let's say, for example, still on simple bots, let's say your bot is just a request bot, like something in Python. It does a bunch of requests, goes all over the place. Turns out you can make a challenge in JavaScript, generate a token that you can later validate. This can be either in a form of a CAPTCHA, this can be in a form of a non-CSRF tokens, plenty of things to do this. If you see this thing is not getting generated, there's probably no JavaScript engine behind the scenes, and that means there's probably no real user there either. So, but let's say they do run JavaScript. So the question is how they run JavaScript. This thing is still relevant today. Real story, I saw this in production not too long ago. And the funny story about Internet Explorer, despite Microsoft's best attempts, is that in Internet Explorer and only Internet Explorer, this thing is going to evaluate to true. This is going to be true over here. This is because of weird escaping and all kinds of things. But what this means, I know as JavaScript devs, we don't like this stuff, but operators hate it too because you can use these things to verify what's going on under the hood, what they're not actually reporting. This is a pretty concrete detection. We're still in the world of like simple concrete detections you can do to validate whether whoever it is on the other end is playing nice or not. But let's get a little bit more concrete. Let's get a little bit more complicated into the woods of JavaScript. Here what you have is you have, for example, I talked about how user agents boast the JavaScript property and network property. Let's say on the JavaScript property here, you see something pretty bad. So here we have Autobot v3.2. I don't know if you can see this in the font, but the first line over there, not so nice. As the bot operator, you want to hide this thing. And it's read-only. So you can't just, like on your script or on your site, you can't just change that value. Turns out, like most seasoned JavaScript devs here, no, you can still override these things property. So what you do is object.define property here, you override the getter. Then when the detection side folk are trying to catch you, they're trying to override that thing, they check your navigator.userAgent, looks perfectly fine. And the bot scheme goes on, they're very happy. What turns out keeps happening, and this is one thing you should actually remember, a lot of these times when they do this patch, there's going to be an artifact left behind, something that the detection fault can know actually pointed out to how this whole thing happened. So in this case, if you do it like this, what you can see is the property descriptor. Property descriptor for user agent is supposed to be null. As the detection side people, you see that somebody's playing with this value. You see somebody's trying to hide something. You look into this thing, you look into the function, very quickly understand how the bot operator is doing their thing, and then you block it, and this whole cat and mouse game is the key point of this part. Now, funny little thing, you can do this with toString if the operator is not, if the property you're messing with is not read-only. You can override the toString, then you can check the toString off the toString. You can override that too. Fun little game established. Point here being, if you're really good at this, and this is, I heard from some people that they really care about bot detection. There's plenty of good solutions out there. Main one I'm gonna kind of recommend here is Creep.js. Very good library. What it does is it tests the DOM, and it fingerprints the browser underneath the hood and tries to see if the story you're telling is matching what's actually going on behind the scenes. The issue with this is when you have an open source solution like that, the bot people, the bot operators, they're not going to just stay there. So they see they're being detected. They see the JavaScript line that is detecting them. Reminder, this thing is open source. So they're obviously going to patch whatever it is they're doing, so it only goes so far. But this is like the 2080, so this is like the easy thing you can do to really get a gauge of what's going on behind the scenes in whatever it is you're using. But this drove the whole bot operator thing, the bot detection thing, I'm sorry, to look at a whole other angle here. So privacy is a big issue in 2022 with data. It's super tricky, especially where I work. DoubleVerify is a third-party service. We really care about this thing. So when you're running in a lot of places, you really need to know what you collect. But I'm going to put this to the side for just a moment and assume you have, let's say, a site for the sake of argument, and that site, the user goes through the site, every little API call they make, every little page they open, you can track the user with some sort of a token. All of a sudden, a whole new arena for catching bots. You can see nonsense navigations, you can see duplicate tokens. That whole thing can reason maybe somebody's pre-programmed your logic. That's something a user would never do. There's actually a little point there because users are actually doing this with caches. Like when I first passed this, like locally, like did a dry run, and somebody asked me, aren't caches doing this too? That's a good point. They're absolutely right. But then caches introduce a whole other avenue for detection. Some people clean these too much. They don't resemble a real user anymore. So that's a whole different way to capture this. And this is how the whole cat and mouse game is going to introduce new ways to detect these bots. But I want to move forward. One last kind of example I want to give is behavior tests. So still in the domain of simple detections. Let's say you know what's a good example of behavior tests. How many times does a user click on your site in an hour? Okay, so there's going to be a little like spectrum, little distribution thing. And you're going to look at the edges, because in the middle, there's going to be all kinds of people, and they're going to click, like, I don't know, 1, 2, 3 times. On one side, you're going to have my dad. And he's, after a long cardiac surgery, just blanking out, and he's having a good time. So not very easy to flag there. But on the other side, you're going to see 172 times clicking per second. Okay, no real users clicking 170 times. There's something there. And moving forward, I want to talk about how the bots haven't obviously been sleeping on their guard all this time, so they got better. And this whole cat and mouse thing that I talked about earlier is so inherent to the game. What happens is you see the bot detection side, they put out a new detection. Bot operators are very sad. Then they try to fight it. And turns out this thing is so inherent that there's a super common repo. Here, what it does is it puts up on one side the most up-to-date detection. On the other side, it puts the most up-to-date bot, like the public solution, runs these against each other and sees who's on top. This thing changes not daily, changes hourly, but the detectors are winning is going to be a little bit misleading there. What I'm going to make here is the game is actually harder for the seekers. Now, if you've been paying attention, you'd say, okay, bot detection, you only need to find out one thing that the bot is doing wrong. And on the bot side, you have to fake everything correctly. If there's one thing that incriminates you, everybody on the detection side is going to catch it. And that would be absolutely right, but I'm going to claim the other thing the other way around. And if this is something that interests you, feel free to catch me after the talk. I'm super passionate about this. Here's the deal. Bots are evolving. Every time you put out a new detection, there's going to be these winners and losers. Losers are not going to be very happy. They're going to patch themselves just a little bit. They're going to change themselves a little bit. They're going to become more and more like a real user. What happens is over time, if 10 years ago we're fighting user agents, we're fighting like simple stuff, all of a sudden now, these people are making Google and Facebook struggle to explain why they can't just remove bots from their platforms. That's evolution. And evolution, not my idea, this guy, he came up with that. Idea there, it's really good at eventual problem solving. And if you agree with me that there's nothing inherently unique to a user behind the keys, it's only a point of time until these people can make a bot that's not just undetected by all current solutions, but wholly indistinguishable from a real person. And they're evolving towards this fast, but I want to bring this back from the whole philosophy rambles. I want to bring this back to practice. So I told you that I'll tell you how the bots are getting better. Biggest game changer in the last 10 years is going to be automated browsers. Little yellow part is not necessary, but the point here being, you now have the browser on your side. We talked about request bots. These guys are not as common anymore. What we see is these browsers help you render JavaScript. You can do a lot with it, and they give you a lot of tools to make your whole operation better. So you can control attributes. If earlier we were talking about patching the user age in JavaScript, you don't longer have to do that. You can use Chromium or whatever it is to patch it on the browser level. Very hard to detect on this detection side with JavaScript. Makes bots a lot more flexible. Another thing, we talked about browser quirks. These guys import the browser with all the quirks inside, so you can no longer just catch them on faking the thing if they import all their quirks with the whatever browser that they're automating. And final point there is they have a real good time, real easy time automating the user too. We talked about behavior tests. Here, you can use window.scroll, you can use CPP hooks on Selenium, whatever it is you use. The point is, you can fake the user doing whatever it is you want on the site in a very low level, very hard to catch there. So, these are all common solutions. They all rely on Chromium. We like open source here. Chromium is an awesome project. So I've been researching vulnerabilities and stuff on Chromium for a while. And I can tell you I've really grown to like it. Point about these is they're used for the good purposes, for the good guys. So if we're here trying to automate something, if we're doing QAs, if we're doing tests, a lot of things we're going to be hearing about in this conference, these are going to be just fine. And there's a lot of plenty good solutions that I've heard out there just in this conference. But they're not good for this whole bot hiding thing. The browser's not on your side when you do it. They're not good at hiding the fact that they're a bot. It's not just JavaScript artifacts. It's just they're not meant to do it. So on behavior, you're going to cache them very fast. If me and you are doing a little bot scheme over here, you don't want one of these. You want something based on this guy. Not malicious, important to note. This is Google's automated browser. It's called Puppeteer. And it's not trying to hide, but it's really easy to extend. You script on top of it with Node.js. We all like Node.js here, right? Show of hands. All right, awesome. So yeah, whether you like it or you hate it, you probably know it's very, very easy to extend on top of this, much better than the other browsers in my opinion. But what's nice about this guy is it's very smooth to run, very easy to extend, and all these pieces coming into place gave the birth to what I like to call the king bot. So we have automated browsers improving, we have bot operators trying to make their game better, and we have all these things coming together, and now we have the main player of this show, going to be called Puppeteer Extra Stealth. Puppeteer plugin, Extra Stealth, PEZ, whatever you want to call it, it's just miles ahead of the competition. So Puppeteer Extra Stealth, what it does, it runs headless by default, meaning it can run with no GUI attached, no window actually opening. It's still better at faking all the GUI-related things better than any other browser. I'll talk to you more about this in just a second, but I want to focus on how this beast works. First, we're going to talk about Navigator prototypes. So this used to be a good way to detect Puppeteer. This was out there. And the community behind it is an open source army, just looking for the tiniest thing that can allow you to detect them. They're on the internet everywhere, all the time, just trying to find the moment you slip up. And they often patch these things before we even deploy them. Here, they're trying to patch hardware concurrency. So it's important I explain this. Hardware concurrency is like how many processes you can run in tandem. They're no longer in the playing field of trying to avoid detection. They're now in the playing field of avoiding any kind of suspicion. Turns out when you do a whole bunch of evasions like this, one way to detect them in the data is going to be the data is too clean. But here, what happened is, they had a value that could incriminate them if you run many instances in tandem. So let's say you have a Docker, you raised it on like one of the automation platforms that one of my buddies here in the conference talked about. You run these at scale. If you run many on the same computer, it's headless, so it's pretty easy, not that heavy on performance. You could detect that they're not running that many in tandem. So to try to patch it, they accidentally left a small artifact behind on hardware concurrency. You could detect in the prototype, they had a bad value there. Obviously, they found this fast and they patched it. So let's take something more complicated. I said Puppeteer is headless. Headless means no GUI. And one of the detection side things that works very, very well is going to be canvas fingerprinting. This is when I load a canvas dynamically on my screen and I run it. And I'm trying to fingerprint the browser and underneath it, the operating system and the graphics card. And I try to understand from whatever timing the dynamic thing takes, there's entropy, I can understand what's going on behind the scenes. So what you'd say here is, Adam, there's no way a headless browser can fake this, right? Because this is working on graphic rendering, and it by default doesn't graphically render anything. Turns out, bam, these folks develop an extension. What this thing does, it detects when it's fingerprinted very, very well, reports fake values in JavaScript. And they have this thing just where whenever you find something concrete that's good at detecting them, canvas fingerprinting, very costly in terms of real users running it. That costs you on performance, on privacy. Here you see, they just solve these things, and if so many people use them for detection, they just implemented default on the projects. We're going to talk about how seamless it is to integrate these things on Puppeteer Extra Stealth. They're really, really good at this. One last point I want to run through. I want to just explain how one of these detection works. Before I fly through the others, because there's a lot of them, and they're really fun to talk about. Here, what you see here is a code that I looked at a lot in my previous job, reverse engineering Google. What you see here is the code that loads the runtime object of Chrome into the navigator. So this fills in the Chrome CSI, Chrome app, Chrome load times. I don't know, like probably most of you know these objects. But the point here is that if Chrome is headless, these don't get populated. These are never generated. And you'd say, okay, I have a good way to detect when a headless browser is running. Maybe I can infer it's Puppeteer. Not so fast, buddy. They fixed this. They fixed not just this, you see over there in the middle, I don't know if the font's too small, Navigator hardware concurrency, they populate these values, they add them in. They fixed so many things. They fixed like Chrome app, CSI, load time, runtime, hardware concurrency we talked about earlier. It's going to be Navigator languages, so when you run a headless version of Chrome by default, it has a different number of languages. Obviously, they patched that. There's some really complex stuff too. So some of these overrides are not just an attribute, Some of these can be like a whole behavior, like we talked about canvas fingerprinting, that these guys fake. They're really good at their thing. And one thing you might be asking yourself is, hey, Adam, we have a thing that's supposed to distinguish bots from humans called CAPTCHAs. Well, CAPTCHAs are a super boring tool, but this is going to be super insulting in my opinion. Just 2 lines. 2 lines, you solve the whole thing, no CAPTCHAs. You just 2 lines, a little bit of money, and no CAPTCHAs on the internet. Super, super fun. I think human-based solutions are better than machine-based solutions up to this point. But either one you use, you can just replace the solution here. Point being, CAPTCHAs don't stop bots. They slow them down a little bit. This is why you still see these on the web. And these Puppeteer folks are super easy at this. I've been talking to you about all these different things that you get. You get the evasions, you get these extensions that fake all these values, you get all the help at avoiding detection. Now this whole thing is going to be a node library in these 2 lines. So if I want to make a state-of-the-art bot out there right now, if my little sister wants to make a state-of-the-art bot right now, she's not a computer junkie, she can just add these 2 lines to her code, and then it becomes much harder to detect. Everything we talked about comes in here. So this is a state-of-the-art, one of the bot tests, and Puppeteer obviously like overcomes this thing, Puppeteer Extra Stealth. This one's funny. They hang this over the repo like a trophy. They put this one in. So this is, we talked about canvas fingerprinting. This is a lot of kind of headless tests that are meant to catch it. Puppeteer Extra Stealth is better than a normal browser at catching bypassing some of these tests. So they're really, really good at seeming very, very close to a real user. And they're super accessible too. So this is making real good bots real accessible. They're entirely free. I don't know if I mentioned that. So open source software. Some of you have been here before the presentation. I told you something interesting I can't repeat at the moment. I'm sure some of them are listening. But point here being, and this is my favorite part of the presentation, there's still some things that work. So obviously, I can't go into too much detail here. I did get acceptance from where I work to talk about a few things. I'm going to say way more than Google does, but or researchers would tell you. But I'm going to do it very quick because I can't go super deep into details. So first, we talked about easy bots, stuff that relies on the wrong kind of browsers. Obviously, you can block this stuff with like any kind of attribute detection. Look into Puppeteer Evasions, super, super easy to do. Solutions like Group.js we talked about, very easy to detect. But for the hard bots, first thing we're going to talk about is JavaScript engine artifacts. So remember when we talked about hardware concurrency? There's still some stuff like that. The upside of it is it's very concrete. So once you find it, that thing is yours. It's hard to find. These people are looking for this stuff very, very closely. But if you find something like this, then you have a detection. This is something that I believe will eventually get patched out. We talked about how these bots are evolving. These are not going to be around forever. But if you have one of them, you're going to be very good at detecting all these kinds of bots. Another thing, there's going to be 2 points here. Browser behavior tests. I can't talk about this too much in depth, but basically, you test different JavaScript contexts. Typically interacting with the DOM, these browsers behave a little bit differently, these bot browsers. And one thing that I can is data tests. So data, it's funny, because let's say you're able to fake the user agent. You do it at whatever level. You can do it at the browser level. And the question is, what do you put in there? So funny question, like you could put any good user agent, but when you run a really big bot scheme, some things are going to turn out. This here, I know it's blue, it's the fraudulent part, so this here is going to look pretty nice. The x-axis is different user agents, different common user agent values, and the y-axis is how many times did I see the traffic come with that user agent to a specific website. App in this case, but let's say website just to keep things simple. So what happens is you'd say, okay, there's some variance here, which is nice, but how this thing is supposed to look like is like that. This Pareto distribution, this pattern comes around. The most common user agent, for example, for Chrome, is the vast majority of the traffic, and in reference, this blue thing is almost flat. So what turns out, the fraudster, they got right that user agents vary, but they got wrong the weights. They got wrong how do they vary. So what I bet is like maybe they have a random user agent generator out of a bunch that are legitimate. Maybe they're doing this with like a round robin where each time they're dragging out a different user agent. Now you see something like this, the most common version, not there yet, because I cut this the moment Chrome updated. The bot scheme did not upgrade this. This way, you're actually able to get a good lead into what Puppeteer traffic looks like right now. Obviously, these bots are making many small modifications in their code, and all these private solutions that are really good at their thing, they're hard to find, but I look at this one, led me into a very nice scheme that I was able to detect. So yeah, data tests, pretty good at detecting these bots, because the question is how they're doing whatever it is they're doing. And I love going low level. I'd love to talk about this whole thing so much more. Oh, one slide before that. Hold on. I asked you what's going on the web at the start. And I don't know what to tell you. I'm looking at a lot of bots every day. This is something I'm very passionate about. I look very low level. I reverse engineer these automation solutions to find even the tiniest difference. But what I do know is we need a lot of good people like you, when I ask what's going on with bots on the web, to be aware so that the internet becomes a better place. Thank you. Nice to see you, and feel free to reach out. Do we have time for Q&A? Yeah, okay, awesome. Is there anybody? Raise your hand, feel free. Anything? Take your time. I know it can be real hard. People get shy. Hello, yes.
If you get really good at detecting bots, are things like UI automation still possible for that app?
Excuse me, what did you say? I didn't hear the second part.
If you get really good at detecting bots, are things like UI automation still possible? Because they are simulating a user and pretending to be a user.
Mm-hmm.
Do things like Selenium, things like that.
All right, so question is, when I talked about behavior tests, I was talking about automating UI. So that can be window scrolling, that can be playing around with everything. And the question was, if you get really good at that detection side, can you still fake UI interactions as one of these malicious bots and still not get found? What I saw is, recently, you've been here before the talk, so you heard a little anecdote. No? Okay. So I'll say this in a sneaky way. I have a good reason to think some of these bots are using artificial intelligence to fake real users. So what you see often is if you just fake to be the most inactive user, 9 times out of 10 you're going to pass, because there's a lot of these inactive users, they do nothing. If you do nothing, it's very hard to do something wrong. But if you're a big fraud scheme, you can just have all your users do nothing. That's suspicious. So you use artificial intelligence and you see what gets detected and what doesn't. The detection solutions are public, many of them open source. And these bots, they can see what you're collecting in JavaScript. Sometimes they can even see your logic if you do it on the client side. That's one thing I think many detection solutions can do better. But when you see how you're getting detected, you can really try to patch yourself and improve until you don't get detected. So that thing, UI automation, is still prevalent out there. People are still doing it well, and the detection solutions still can't detect it 100% of the time. Hello?
So the industry that we work in, just that's a serious problem. So are there libraries out there that have some of this basic level detection in it, and that we could start including in our JavaScript, so we can at least get initial stuff, just to get some of the basic stuff, even if it's not fighting Kingbot.
For sure. So question is, let's say you're in an industry where this thing is super prevalent, whatever it is, can be social media, can be concert tickets, anything I talked about or something else. What's an easy library that kind of does this thing? How can you start? I talked about Creep.js earlier. They're really good at DOM testing. Issue with that is if you're really concerned about privacy, sometimes their fingerprinting can be a little bit too much. There's other solutions. So there's Antibot, there's Antibot.js, there's Creep.js, there's another thing you could do. I know this is something that, that's the easy solutions a lot of people tend to do, is let's say you have a social media, you look at what Facebook is doing, you look at their JavaScript, you see what library they're doing, and you copy it. Often a lot of these people use open source solutions that are just very easy to replicate that will help you with your specific industry and your needs. So if your industry is super privacy heavy, that's something you're really passionate about, then maybe you'll use another solution. If your industry is something that really cares about performance, I see a lot of time people run microservices and performance is a very heavy point. So there's specific solutions around that. One good one that I recommend starting with is Creep.js, very good detecting a lot of bots.
What other resources are there that do research
On what?
blogs? Well, just figuring it out. Detecting bots.
What's a good places to research or learn? Yeah, for sure. So shout out to my place of work, DoubleVerify. They have a blog about this, tech blog. I've been writing there some a little bit. Salespeople have been writing there some a little bit. I figure out like some of the articles might be some more like tech related. That's something that might be interesting for you. Otherwise, a lot of these bot detection solutions also offer some. So I know Google, for example, they have reCAPTCHA, but they also have good teams that are in charge of this kind of things. They also have a nice blog. The name escapes my memory at the moment, but I promise I'll reconnect with you. There's also like the open source community. So if what I did to get into this first is I found a couple of good anti-bot solutions, I got into these communities, I was looking to contribute, and they point you out in a myriad of different ways. So it depends on what kind of bot exactly you're trying to detect, if it's something that's more scraping oriented, if it's something that's more like messing with fraud, is it trying to fake a real human behavior? So the solutions kind of vary, but what you do is you find whatever solution works in your industry, and usually there's going to be a few communities around that, and that's a really good starting point. Okay. Thank you very much, everyone. It's been an absolute pleasure. Feel free to reach out. It's been very fun.